I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 24th. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into producing big waves in the North Pacific Ocean, and we'll look at a very real potential for snow over California in the coming week. Let's get to work. Looking at significant wave heights for the North Pacific Ocean, we see remnants of a gale, still producing some seas in the Gulf of Alaska, pushing into Canada, but of more interest, a cutoff low developing just east of the date line, supposed to make some decent seas, aimed towards Hawaii, and then east winds producing wind swell pushing towards the Philippines. Let's get to it. As usual, we start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, and we see a definite trough here, though rather steep and pinched, right here on the date line. So a trough, you see the winds flowing into it, down and around and back out of it. That helps create a counterclockwise flow aloft, and that is, of course, the sign of low pressure. That also manifests itself down at the surface, and of course, low pressure generates wind, if it's deep enough. Winds generate seas. Seas, as they radiate away from the fetch area, sort of groom themselves out, turning to swell, and swell, when it hits your beach, creates surf. So we see a trough right there. We also see another trough, sort of we call a backdoor trough. It's pushing inland, then it comes back out over the ocean off of Southern California. Now, this is a weaker trough. It's not really generating anything, but it has been helping to produce a bit of an offshore or a weak wind flow over California for the past couple of days. Unfortunately, that is quickly coming to an end. All right, let's put this into motion, see what's going to go on. So we get into Monday, we see the trough here getting very pinched. That creates very little room here for low pressure to develop and is less favorable for gale development over, let's see, what is this, as of Monday morning. We also see a ridge that is the jet pushing to the north off of Japan and over the Gulf of Alaska. That helps create a clockwise flow, and that's the hallmark of high pressure, and high pressure does nothing for generating the kind of surf that we're really interested in. Yes, it produces wind swell, but not a long period swell. All right, so we move into Tuesday. The cutoff, the pinch trough becomes cut off. You notice the jet pushing completely over top of it. And then we start seeing a new sort of trough trying to develop Wednesday morning off the Pacific Northwest. Good amount of wind falling down into this. What is that, about 160, almost 170 knots? And that continues through Wednesday, pushing down the California coast. Now, this is so close to shore that, yes, it looks like it'll produce low pressure, but that low pressure is like half over land, half over water. Probably more of a wind swell producer than anything, but we'll keep our eyes on it. Certainly a weather producer, and that is the more important part. Cold air. Notice the jet goes way up here into Alaska, then pushes in Canada, then down south, bringing cold air with it and some precipitation. And then it moves inland on Friday. We also see another trough, kind of a pinched off trough again. When does that start? It actually started somewhere around, we'll say Friday, and falls southeast through the Gulf of Alaska into Sunday, and then circulates off the California coast all day Sunday into Monday, and boom, there you go, another backdoor sort of trough situation setting up. Now notice off of Japan, the jet stream kind of split, not really organized. There's a little bit of a head scratcher here, and you'll see why when we get into the longer-term MJO discussion. We would think that, if anything, the jet should be pretty consolidated and pretty energetic. And it is energetic in pockets off Japan, ridging up over Alaska, but not in the classic sense that we would want, with the jet just like barreling off about 40 degrees north and then dipping somewhere over the dateline of the Gulf of Alaska. So kind of a convoluted pattern here, but we'll get into that later. All right, let's go take a look at the surface. What is you can see what's going on in the jet stream. That influences what happens on the pressure and the wind patterns down at the ocean surface. And of course, it takes wind on the ocean surface to make waves. All right. So here we are, surface level pressure, surface level winds. We see a gale, the cutoff gale, developing that trough Sunday, just east of the dateline. Small area, 45-knot north winds developing, building in aerial coverage Sunday night, and then into Monday, holding about 45 knots, holding position, fading out later Monday, 35 knot winds, all aimed, we'll say, generally south, maybe even bypassing Hawaii a little bit. The low continues, cut off into Tuesday with 30-knot winds. You can see it there. Now, as that starts fading, notice what's going on. We'll go back one frame here. Tuesday morning, we know the jet also starts making a bit of a trough very close to the coast off of the Pacific Northwest on Tuesday. By mid-morning Tuesday, 55 to 60-knot winds, that little purple right there. And that continues south off of Cape Mendocino on Tuesday night, starting to build inland, still 45-knot winds late Tuesday night off Cape Mendocino, and then the core of the low moving inland on Wednesday, but still a broad area of 30-plus knot north winds raking down off the Pacific Northwest coast and just targeting California with, at least from Point Conception northward, with good odds for raw, pretty large, very north-angled swell. Then on Wednesday, the gale starts fading. But whoa, look at this. Let's go back. Now we're going to go back. So there's multiple systems you can see going on. On Wednesday, another low starts developing in the, we'll call this the Western Gulf, with first 35-knot winds into Wednesday night, 45-knot winds and 40-knot north winds, targeting Hawaii pretty well. Building in coverage into Thursday, a broad area, 40 to 45-knot winds aimed down at Hawaii well, but also somewhat at the U.S. West Coast. We get into Thursday night, more fetch aimed at the U.S. West Coast and at Hawaii, very north angle for Hawaii. And then it fades, starts falling southeast Friday, still 35-knot winds, and still 30 to 35-knot winds Saturday morning, pushing towards California, continuing Saturday night, and then what? Regenerating again on Sunday? So you get the general idea. A bunch of fetch, a bunch of winds, sort of aimed initially really good at Hawaii, not particularly well at California, but still sideband swell for sure. We're going into, here we go, Sunday night, a week out, northeast fetch aimed back at Hawaii. Hawaii for sure getting slammed by this one, but certainly some degree of swell for California. High pressure, strong off of Japan at that time, 1036 millibars. Here's that east winds, supposed tropical systems. Interesting. That is another sign that we need to talk about as we get into the MJO section. All right, let's go take a look at the effect of those winds on the ocean surface. Here we are, significant wave heights, but we're going back in time first because last Wednesday, November 20th, a little gale developed off Japan, 30-foot seas, continued to the dateline, still 30, 32-foot, sort of redeveloped, built a small area, 37-foot seas on the north dateline, then raced off into the Gulf with 35-foot seas on Friday morning, and then fading out from there. The point being, that swell is just starting to hit Hawaii now. Some decent-sized sets rolled into pipeline this afternoon with decent wind conditions. A little bit rawer elsewhere on the North Shore. Some of that energy moving towards California as well. We'll roll this out into Sunday just to get us caught up. And here's the beginning, 18Z Sunday, of the new cutoff low developing on the dateline. And now let's go to the future. What's supposed to happen? Well, this low, cutoff low, builds rapidly. 28-foot seas on Sunday evening, building to 30, just barely 30 feet for a second there. By Monday morning, back down to 28 feet over a small area, falling south, and fading from there down to like 22 feet on Tuesday morning. Some sideband energy undoubtedly moving towards Hawaii. But also, let's go back. Notice off of California on Monday. Now, this is more wind swell. This is not gale related, but you notice small area, 22-foot seas building Monday night off of Point Conception. That's wind swell for sure for Central California and maybe wrapping into select Southern California breaks. All right, then we move on. Tuesday, midday, new gale developing off of Oregon, building rapidly with what is that? 43-foot seas forecast over a tiny area, and then pushing south into Wednesday morning, still 29-foot seas right off of San Francisco and Point Reyes on Wednesday morning. Large raw swell sweeping into that area, falling south from there. Probably pretty stormy, miserable conditions. So we get into Thursday, the seas start dissipating. Still, wind swell for Thanksgiving, or even, we'll call it semi-swell. But of more interest, back out in the northwestern Gulf, new gale developing yet again. 34-foot seas aimed well at Hawaii. We know how this guy's going to go. 34-foot seas continuing into Friday, down to 32-foot seas, tracking southeast, targeting California well with, let's see, we'll just go right to Saturday morning. What's that? 26-foot seas, and you can see the raw energy pushing into Hawaii at that time and energy towards California. This system continues just generating, we'll say, 24-foot seas off the coast. Oops, and there we go. We're at the end of the frame. The short synopsis is plenty of swell to be generated over the next week. The not-so-great portion of it relative to California, things to be pretty raw. The better thing for Hawaii, not so raw, and a good, solid north-angled swell looks possible. All right, let's move on. So normally we use this chart to look at wind swell potential, but I think for the purposes of that, we're going to be more interested in just generalized wind conditions, if not storm conditions. Now, interesting, high pressure, double-barreled high pressure thing. We'll pull the controls away there. You see one at both the centers at 1034 millibars there, driving some fetch along the California coast. I mean, it was not bad at all today, even in Northern California. In the afternoon, yeah, a couple hours of 15, 20 knot winds, but it settled down by evening. Hawaii, broad area. You see this, all this 15, 20 knot easterly trades sweeping over the islands, building wind swell, offshore winds. Pretty strong, though. Strong trades for the Hawaiian Islands. So we get into Monday. Now, notice, high pressure building starting to take aim on California. 30 to 35 knot north winds along the California, we'll say the North California coast. The dividing line we say is San Francisco. 30 knot winds just off the coast early, but by the afternoon and the evening, 35 knot winds over all of North and Central California. Just a wind-blown mess. Yeah, plenty of wind swell, but after the relatively calm, clean, groomed swell of the past weekend, this is just going to be a complete mess. Trades for Hawaii continue. Look, it's 20. Okay, so 20 knot, almost 25 knots. Each one of these isobars, roughly 300 nautical miles. So 3, 6, 9, 12, 1,500 nautical miles of fetch aimed at Hawaii, 20 knots or greater, other than the 300 miles right there by Hawaii. For sure, wind swell. More of the same on Tuesday. The fetch relative to California, that wind swell starts fading out, but here comes the storm. Very tightly wrapped isobars. What is that? That's 50, 60, almost hurricane force winds off the coast of Oregon. Moving, there, clearly, 65, what's that, 55, 60 to 65 knot winds. That's hurricane force pushing into Cape Mendocino on Tuesday evening, only for a short period of time, thank goodness. And the presumption is a fair amount of precipitation with it. That should mean probably not fire danger, but just a lot of wind, a lot of blowing, and the same working its way down the coast. A real mess on Tuesday night, Wednesday for California in terms of wind. Only the most protected breaks will probably be Rydell. You get into Thursday, Thanksgiving, notice the low starts fading out. Lighter wind situation. Also notice trades backing off for Hawaii as you get into Thanksgiving morning. Light, probably not so bad of a day in California as you get through Thursday. Friday, winds, what do? Out of the north, not horrible, but still kind of messy, nothing great. Trades continue for Hawaii, pretty strong, but very local. Next low, moving into the areas. We get into Saturday, light wind situation on Saturday, if not turning east-southeast in North and Central California. And then into Sunday, stronger southeast winds for California. Northeast winds. Actually, let's go back and look at Hawaii here. were trades on Saturday, but as we get into Sunday, notice the high here and the low there, but it's this turning of the isobars to the, it still looks pretty much out of the east for Hawaii, but then turning a little bit northeast as we get into Sunday. Not sure how clean it's going to be on the North Shore on Sunday, and certainly a south to southeast mess as we get into at least North and Central California and even down into Southern California, just much weaker. So a lot of wind to have to deal with. You have to pick and choose your spots carefully. All right, let's go take a look at all-important precip potential. So here we are. You see, and we're only focusing on California. We're really interested in rain and snow. We know we have low pressure building off, later Tuesday, and there you see it coming in. Deep isobars. Let's see that slam into the coast. Boom. And notice, cold temperatures too. The model is showing snow just inland everywhere. It's not even rain. It's snow. And building strong into the Sierra, hard over Cape Mendocino on Tuesday night into Wednesday. Solid snow event. Continuing through the day Wednesday. Rain down into... Well, actually, let's go look at the rainfall progression here. Okay, rain starting in the Bay Area on Tuesday night, sweeping south all day Wednesday into Southern California Wednesday morning, continuing through the day, snow in the Sierra into Thursday morning, light rain along the coast on Thanksgiving, even down into Southern California mountains there. Interesting. And then drying out later Thursday for North and South California, then finally for Southern California, maybe even lingering showers on Friday, and then drying out for sure on Saturday. Everything looks good until we get into Sunday. Oh, the rain just touching the coast. Kind of wish it would make it into the Sierra, but it doesn't, and that's the end of that. So mainly one big event for the California coast on, we'll say Tuesday, Wednesday. A quick look at just the overall snowfall charts for the southwest U.S. There's also a link down here. If you go to the main menu on Stormsurf, go under the snow models. There's a northwest link as well now, too. This is the GFS 240-hour view. We're mainly looking for, and you can see snow inland for Colorado, but we're focusing on California. Here we go. We get into Tuesday, 6 p.m. You can see the snow building over the Sierra. Was that 13.11 inches up in Cape Mendocino at 6 a.m. Friday? That's just for a 6-hour interval. Then you see it sweeping down over the whole Sierras, 9 inches in one little pocket there on Wednesday. And, we'll just roll through this. You get the general idea. A fair amount of snow for the Sierra continuing into Thursday, then fading out on Friday. The system moves into the Rockies on Friday. Not as much snow, but still snow there. Then we roll this out. Now, this model goes out 240 hours. A dusting of snow over the higher elevations of the Sierra, mainly around Tahoe on Monday. And then that's pretty much it. We'll roll this out. Oh, and that's it. Yep, that was it. All right, and we don't believe a model 240 hours out, but you get the general idea. Quick look at a couple resorts. Squaw Valley, snow potential forecast. What's that looking? Oh, like about 32 inches. You can click the image and zoom down there and see. Yep, 32 inches. Okay, not so bad. Let's go back. And we'll look at snow levels. Here we go. So this is the base of Squaw. Each one of these snow level charts are built for the particular resorts. The heavy line is the base of the resort. The top line is the highest peak. If you see reds, that's above freezing temperatures. So the freezing temperatures are below the base of Squaw from, what is that? The 25th of November. The whole way through till about December 2nd, and the yellow line is where snow's happening. Wind potential, yeah, pretty good wind, 100-mile-an-hour gusts over the peak as we get into, the main event of the storm, another with 90-mile-an-hour gusts. The good news is it's only for a very short period of time. So certainly snow for Squaw Valley. But the good news is we go south, and that's pretty representative of everything for Tahoe. We go down to Bear Mountain in Southern California. They're still looking at, we'll say 20 inches, 22 inches, something like that through this event. Snow levels below the base of Bear. Wind, pretty strong, 80-mile-an-hour gusts and 65, roughly, something like that. That's up at the peak elevation. This other line here is mid-mountain wind and gusts, so you can sort of know whether you're going to get access to the top of the mountain or whether you'll still be limited to mid-mountain, or if the gusts are hard and strong, wind is strong enough even at mid-mountain, maybe no skiing at all. But anyway, you get the general picture. At least this is the start of building some snow base for all California resorts. Thank goodness. All right, let's go take a look long term. What's driving all this? What's happening with the MJO? We've talked about the MJO before, that periodic weather oscillation. 3 weeks in the active phase, 3 to 4 weeks in the inactive phase as it crosses the Pacific on the equator, moving west to east. That helps feed the jet stream in the active phase, or sort of stomps on it during the inactive phase. And then, of course, what's going on with El Nino or La Nina? Where are we? All right. So to monitor the MJO, we like to monitor winds on the equator. These charts from the TA buoy array, series of buoys strung across the equator. This is the equator here. This is the East Pacific here. This is the West Pacific. That's New Guinea right there. The date line right there. All right, so we're just looking at the arrows. The colors are water temperatures. We're not interested in that for the moment. We see strong easterly winds over the East Pacific, making it about to the date line, and then they stall. And what do we see in the West Pacific? Well, right, and it's only 5 degrees north and south of the equator. Really, this area right here from 170 west, 5 degrees north and south of the equator, that box right there, we call the Kelvin wave generation area. When you get west winds for a long period of time, or west anomalies actually, this just means trades weaker than normal in this area, warm water, those reds that are right there, they start moving off to the east, but not on the surface, under the equator in what we call a Kelvin wave. And if the west winds last long enough and are strong enough, that they'll create a Kelvin wave that'll push the whole way across the Pacific, then erupt off of Ecuador to the ocean surface, create a warm slick over here. If you get enough successive Kelvin waves, and it takes 3 months to make the journey across the Pacific. So to get 3 or 4 of those, it would take almost a year, and you get it. And if they build up a warm slick over here, then that's how you get El Nino. All right, so right now, looks like we have west anomalies building pretty solid over in the Kelvin wave generation area. Well, actually, those are west winds. Those aren't even anomalies. So that is typically a sign of the active phase of the MJO. When it can reverse trades over here, that's the active phase of the MJO, make them from the west. That also imports energy to the jet stream. And when the jet stream's strong, that helps feed the storm track, making not only surf and swell, but also precipitation in California. So all this is interconnected. It's one giant interconnected system. You just have to know what pieces to look at to know what the system is doing, what it's thinking. All right, so what we're really interested, though, is anomalies, the differences from normal for this time of year. Yeah, those east winds look pretty strong, pretty menacing, but looking at the arrows here, yeah, they're a little bit stronger than normal, way over by the Galapagos, but elsewhere, the arrows are really pretty much doing nothing. It's kind of neutral. And even more impressive, look at the arrows in the Kelvin wave generation area. Again, this area right in about here, strong westerly anomalies, a clear sign of the active phase of the MJO, and that's exactly what we want because that feeds the storm track. So what is the forecast, and how long have these westerly anomalies been blowing? Okay, so this chart is 850 millibar zonal wind anomalies. Fancy words for what's the wind doing about 4,700 feet up in the air, but that's a good proxy for what's going on down at the surface. This is the whole planet on one chart. So we know the date line's at 180 west. Kelvin wave generation area goes from about 135 east to about 170 west. So between those two tick marks, that's going the whole way up the chart. That's what we're interested in. Though the Pacific goes the whole way over to about 80 west, somewhere right around there. But we're not so interested in that. So we see reds, westerly anomalies, and pretty strong as of right here. That's today's date, the 24th. Filling the Kelvin wave generation. Hoorah, that is good news. And notice, this has been going on since just after Halloween. So, the active phase of the MJO was supposed to die about mid-November, and no model, Nothing picked this up, but all of a sudden, like last week, it just said, hey, I'm going to wake up again. And here it is, fully pulsing, westerly anomalies in control, and forecast to hold through the end of the week. This is really good news. Let's go out 2 weeks. All right, so this is a different way of looking at it, and this is outgoing long wave radiation. So the MJO is not just about east and west winds, it's also about precipitation. It's really about the MJO. The MJO is like either a low or a high pressure system that traverses, you can see it right here, on the equator from west to east. So low pressure not only creates lower pressure, but it creates westerly winds on the equator and also creates rainfall. So right now we're looking this yellow. What's that? More sun. This is outgoing long wave radiation, sunlight reflectivity on the ocean surface. So more sunlight than normal. That sort of means high pressure. But notice as we get 5 days out, hey, less sunlight than normal. And then we get 6 to 10 days out, a lot less sunlight than normal, and then that moving to the dateline. So this sort of looks like another pulse of the active phase of the MJO. This is per the statistic model. The dynamic model we're going to show you, but it's just a really messed up thing. It's not working right, so we don't have that data to show you. But according to the statistic model, it looks like another pulse of the active phase of the MJO moving through the Kelvin wave generation area for the next 2 weeks. And that's sort of consistent with what we saw on the wind model too. So then we look at phase diagram charts. This is another way of looking at the relative strength of the MJO. So there's a circle in the middle here. See that? So assume you're looking down on the North Pole, and that's the circle. And the MJO travels the whole way around the planet from the Indian Ocean over the Maritime Continent, across the West Pacific, underneath the United States on the equator, across the Atlantic, across North Africa, back to the Indian Ocean. The heavy dot is where the active phase of the MJO is, and the further the heavy dot is away from the circle here, like if it were out here, then that shows you the relative strength of the MJO. So here's the MJO, pretty weak over the Indian Ocean, active phase, supposed to move into the West Pacific, about a week out, and then into, we'll say, the East Pacific from there, but getting stronger all the while. That's over the next 2 week period. That sort of favors precipitation into California. Here's the upper level model. This is again sort of it is a precipitation chart, but at jet stream level. So it just sort of shows the areas favorable for precipitation, which can be loosely interpreted as the active or inactive phase of the MJO. Greens are areas favorable for precipitation. And this is about a week ahead of what's actually going on at the surface. So you see precipitation potential in the West Pacific today, and you can see there's South America. There's New Guinea there, Australia, the Philippines. The equator is right there. So you see, we'll call this the active phase of the MJO, traversing the Pacific through about, almost Christmas, December 20th or so, followed by the inactive phase, an area less favorable for precipitation starting about mid-December, and then traversing the Pacific through, we'll say, mid-January or so. And then here's another one of these charts, the whole planet on one chart, CFS model, 850 millibar winds, so zonal winds. The reds are east or west. The reds are west anomalies. The blues are east anomalies. Where's our Kelvin wave generation area? From here, there's the dateline, to about here. So you go right up like that. You see there? Here's our west anomalies that have been going on since, according to this, since right about Halloween. But right now, getting much stronger, being amplified by, what is this? A red bar. Oh, you can't see it. There you go. Equatorial Rossby waves. So there's multiple waves going on. They interact with each other. It's currently building, but the black contour here is the active phase of the MJ. You can see it moving. So this is the Indian Ocean over here, moving from west to east. Most coherent and it's supposed to hold very solid here through, we'll say, about December 2nd or so, and then weakening and moving out of the Kelvin wave generation area somewhere around, we'll say, December 7th, and then across into California probably December 7th and beyond that. So that might be a period for more rain and snowfall. Now, that's the good news. The bad news is, Here comes the inactive phase of the MJO, building in the Indian Ocean and making its way into the far west Pacific, again about December 7th, and continuing the whole way through to December 21st, and pretty much locking down the Pacific the entire time with easterly anomalies in control. So that would probably not be, well, I'll try this the more positive spin. This would be a great time to go Christmas shopping, is December 7th through the 14th, maybe till about the 20th or so, and then maybe things will lighten up. Also of concern, you cannot miss this giant area of easterly anomalies just locking down the Indian Ocean as it has been for, since August or so. Maybe that'll start fading out as we get into later December, but we have to go look at another chart to get the details on that. All right, so this is the long-term CFS model, 3 months out. Now, if you believe that, don't. But it gives you at least a rough guideline. The model actually does a pretty amazing job considering how far into the future it's going. All right, date line right up the middle. Now, this chart, Kelvin wave generation area between here and here going. But the forecast is from this line going up. This is past performance down here. So here is our area of westerly anomalies that are occurring now in the Kelvin wave generation area, forecast to continue again through about December 7th. Here's what we would guess is the inactive phase of the MJO, the blues, the easterly anomalies breaking out of the Indian Ocean, making a quick journey across the Pacific. Then westerly anomalies return December 16th, 17th, and hold the whole way through Christmas, into the whole way through January, into about mid-February, then things fade out. Let's overlay the MJO here. So here we go. This is the solid contour active phase of the MJO. Now this is interesting. This model is not up to speed. I suspect in a day or two it'll catch up, but it hasn't picked up on the redevelopment. It picked up on the westerly anomalies, but it's not showing the actual MJO component being active out until about December 7th. But we think it will catch up. Either way, it is showing the inactive phase of the MJO from, we'll say, December 7th through about the January 2nd it's showing here. But even with that, westerly anomalies building, then a good solid active phase of the MJO from maybe the first week in January the whole way through to about mid-February, and then that fades out, and we kind of go into a funky pattern after that with no real MJO forcing. The active phases, of course, are where you're going to have most likely odds for storm and surf production. Also of note, the big thing over here, the blocking pattern east anomalies in the Indian Ocean, it is forecast to completely dissipate by about mid-January, something like that. Probably the last bits of it easing out with this inactive phase of the MJO. And then what happens after that? Unknown. Now, the low-pass filter. This is the solid contour. We call that like a low-pressure bias over the date line right now. It's been there. It's actually built starting in early October. 2 contour lines. Interesting. I think last week when we showed this, or at least some point in the week, the second contour completely died out, in the early February timeframe. Now the model's going, no, you're going to hang in there whole way through February. That's good news. If you see this and it's strong enough, typically 3 or 4 contours, one would go, hey, that's really kind of a sign of El Nino, but we're not seeing it. It's not strong enough, but it's a bias towards low pressure development in the dateline region. Also notice here, the dotted black contour, that's the exact opposite. High pressure bias in the Indian Ocean. We were looking at this going, God, this really looks like an El Nino setup, but that's not where we're in. We're in complete ENSO neutral, so we're not going to take that to the bank. We got to dig a little bit deeper to see what's going on with El Nino. So our first stop on the El Nino tour is let's go look at what's going on in the ocean. A major component of El Nino is sea surface temperatures. And it's surface, but subsurface temperatures too. Remember, we talked about Kelvin waves. Well, this is how you do that. So this is the West Pacific here. This is the East Pacific here. You see these little X's? These are the anchor lines and the TAO buoys that are strung across the equator, the whole way across the Pacific, from 2 north to 2 south to 2 north. So that's, and the X's again are the sensors. You connect all the data provided by the sensors and use a little computer model, and you can get a profile of what the ocean surface temperatures are. You see 30 degrees, that's 30 degrees Celsius. Celsius is about 1.8 degrees, so multiply 30 times 1.8 to get Fahrenheit. Anyway, warm water in the West Pacific. Then we monitor how far these isotherms, these lines are moving either east or west over a week or 2 weeks or 3 weeks. So right now, 30-degree isotherm at 180, that's about where it was last week. The 29-degree isotherm was actually, I think it was over here more like 67 or something. It's backtracked to 170. Same thing with the 28-degree isotherm. It was like at 155 or something. It's backtracked to about 160. But the 24-degree isotherm pushing fully into Ecuador. So what's this mean? Well, warm water was on the push to the east a little bit, but it looks like it's backtracking here, but still in the west, pushing well to the east. But a better, more refined view is let's look at the anomalies. Differences from normal for this time of year, and this paints a clear picture. Normally you see cool water in the East Pacific, warm water in the west, but what is this? We see 3 degrees centigrade, almost 4 degrees centigrade in the East Pacific. That is a Kelvin wave. This is Kelvin wave number 5 that's actually been stalled like in the Central Pacific all summer. It's finally on the move. The log jam has been broken. It's pushing into Ecuador. Warm water there. A thin connecting 1 degree centigrade ball of warm water continuing. This is all 100 meters under the equator. That's 300 feet down. A new Kelvin wave. So this is Kelvin wave number 5. This looks like Kelvin wave 6. We've been seeing signs of it trying to fall out of the Indian Ocean for a month now. Fully contained, closed contour line, 2 degrees centigrade. We know westerly anomalies are building here. Have been blowing here since October. So this looks like a new Kelvin wave on its way to the east. That is a good sign. Here's a different view of the exact same data, just a different model, connects it a little bit different, but you can see new building Kelvin. Oh, sorry. Here's the, where's our date line? Date line's right there. This is this is almost into the Indian maritime continent right here, 120 east, and this is the full way over to Ecuador. So new Kelvin wave number 6 building in the West Pacific. There's your date line. There's Kelvin wave number 5. Finally making its way into Ecuador. Pretty warm, too. How many contours? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 4 to almost 5 degrees above normal. That's pretty warm, and that's good. So we have had cold water all summer dominating this area. Finally, this Kelvin wave, or whatever it is, atmospheric momentum is pushing this out, and it's not normal to have warm water over here. Now, we're not saying there's El Nino going on, but there's kind of this bias towards warmer than normal. Is that the PDO, Pacific Decadal Oscillation, showing its signs a little bit? We kind of think so. PDO is like a long-running El Nino, a 20 to 30-year El Nino. And, by this time we should be in some sort of a La Nina, but we're still kind of warmish. Not El Nino, but kind of... certainly not La Nina, so this is good news. The bad news is we had cold water over here all summer. That affected the jet stream some. Yes, we're getting warm water building now. It'll take 3 months for the jet stream to figure it out, and by then winter will be effectively over. Maybe in March, maybe in spring we'll get a little push from this, especially with another Kelvin wave building behind, but probably not a whole lot. Sea level anomalies, so this is basically another way of measuring the same thing, but it's not temperatures, it's the height of the ocean surface. This is like Jason 3 satellite. You strip out all the waves, strip out the wind waves, strip out the tides. You see there's a 0 to 5 centimeter bump here. That's Ecuador right there. There are the Galapagos. This is the equator. There's the date line. So a little bump right here. Warm water at depth expands. Warm water expands, right? So it creates a little bump on the ocean surface. Same thing going on over here. The new Kelvin wave number 6. There's the date line. It's building in the far West Pacific. It's also warmer, making a little bump on the ocean surface. So this is just a way to confirm that what we've seen from the TAO buoy array is also manifest in other data. You always use multiple data sources, correlate them with each other. If they're all telling you the same story, then you have a believable story. But if they're all telling you different things, then either somebody's, we don't want to say lying, but one of the data sources doesn't have a good handle on the truth, and then that makes it less likely that whatever outcome you're looking for is actually going to happen. So here's the historic view of warm water, cold water, whatever you want to call it, and what it's been doing in this Pacific Ocean. Here's the far west Pacific. Here's the east Pacific. You can see this is what Kelvin wave number 3 up here. This was back a year ago, making its way across the Pacific. Kelvin wave number 4, again, created by the active phase of the MJO in the far west Pacific in the Kelvin wave generation area, creating westerly winds, taking warm water in that area, pushing it off to the east. It arrived, well, if it started in January and it arrived in April, so that was 4 months later in the Ecuador area. Then we had these 2 stalled Kelvin waves in cool water in the East Pacific all last summer. It started in May, just kind of this locked pattern. Kelvin waves not going anywhere. Then finally in September, Kelvin wave number 5. This is the one that's currently pushing into Ecuador right now. And then you can see perhaps the beginning of another Kelvin wave here, Kelvin wave number 6, developing in the far west Pacific. So pretty actually active Kelvin wave patterns. They aren't particularly strong Kelvin waves. They're not all making it, obviously, the whole way across the Pacific. But just the fact that there's any Kelvin waves and we're not in some like frozen out pattern completely is more on the side of El Nino than La Nina. Now, we're not saying we're in El Nino. We're just saying maybe slightly biased in that direction. So let's pick up the pace here a little bit. All right, sea surface temperatures. What we do see, and is impressive, warming building along Chile up into Peru and Ecuador. Obviously the sign of that Kelvin wave number 5, which is under here somewhere, pushing into the coast, starting to warm water, cutting down on the cool pool that's been present off of Peru all summer long. That's fading. You see warm water on the equator and then building out towards the date line. This is not El Nino, though. Real El Nino, you'd see a big old triangle of warm water here. But this is, we'll call it neutral, biased warm. And the more warm water that builds south of California, the better for trying to help. It helps feed the jet stream, push it into California. When you have cool water here, it does the exact opposite. It feeds high pressure off of the U.S. West Coast, deflects everything to the north. The temperature trend for the past 7 days, you can see a significant warming trend off of Chile and Peru. This is good news. And then pretty much a neutral trend over the equator. But it's this area really here that we want to see there's been cool anomalies there. We want to see it get wiped out or at least return to neutral. I mean, it hasn't been strong cool, but this is a definite sign or step in the right direction. And in this area right here, yeah, there's warming, but no clear, there is sort of signs that the Kelvin wave is erupting, but not super strong yet. Actual sea surface temperature anomalies across the Pacific Basin. Well, you see a little bit of warming off of Ecuador, a little bit of warming off of Chile. Here's the remnants of that cool pool still lingering off of Peru, but not very strong, not very obvious. Weak warming across the equator. Strongest in we'll call it the Central Pacific right in here, off even into the West Pacific. If you were having El Nino, you'd see big red all in this area. We're not seeing any of that. So this is neutral, biased, slightly warm. In fact, let's look at actual temperatures. Here's the Nino 1.2 region. This is the area right off of Peru, the Galapagos. And you see today's value, 0.202, 2/10 of a degree above normal. But the good news is the trend had been down, minus 2 degrees. And it bottomed out, we'll say, about early October. The trend has been generally upward since. Then you get into the Nino 3.4 region. This is the official El Nino monitoring region, and the trend clearly on the up. Now the scale is different here. This one, again, just like the other one, 0.216 degrees above normal and falling for the moment. We suspect that's going to go up, though, some as this weak Kelvin wave continues to erupt off of Ecuador. What's going on in the atmosphere above the ocean? Okay, a good index is the Southern Oscillation Index. Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When pressure is lower over Tahiti, then the index goes negative. If it's just negative for 3 or 4 weeks, that's a sign of the active phase of the MJO. If it's positive, the inactive phase of the MJO. Right now, we're at minus 10.88 and just scanning down for the past couple of days. You can see it's been negative. Heck, it's been negative all month. Okay, let's go look at the 30-day average. Oh, minus 9.51. Hey, that's a pretty good sign of the active phase of the MJO. And look at that. It's been building from minus 3.96 in the end of October to minus 9.51. Okay, active phase of the MJO. We're in it. Good. 90-day average. This would be a sign, if it was down at minus 15 or so, of El Nino. We're at minus 9.36. Where have we been? We're at minus 6.5, so yeah, we're dipping a little bit, but no clear signs of El Nino. But clearly, it's not positive, so no signs of La Nina either. And then finally, the sea surface temperature trend, sea surface temperature anomaly trend, per the CFS version 2 model, for the next 6 months or whatever it is. All right, so past history, you see, we were in like a weak El Nino pattern with temperatures 3/4 of a degree above normal last winter. That faded. Remember this summer we said it got cold? Sure enough, only 1/4 of a degree in the official El Nino monitoring region, the region 3.4. But then we started warming miraculously in October, 0.4 of a degree in the November time frame. I don't think we're quite there. It's a little bit overstated. The forecast, you can see it sort of hovering just above neutral, maybe 0.2 of a degree into May time frame, and then going weekly negative as we get into next summer. So maybe a repeat of what we had right in here. Who knows? But for right now, we are on the positive side of the 0 degree line. That's exactly where we want to be. So quickly, to wrap things up, a series of storms local for California and a system north of Hawaii, 2 systems actually north of Hawaii, will be generating swell for the next week. Conditions a little bit messy along the California coast. Pick and choose where you go. But even better news is rain and snow, and a pretty healthy dose of it expected for all California resorts. That is good news. Finally, the season will be open. At least the green runs will get some opening with 3 feet of snow. That's good news. And longer term, we'll see. The MJO is supposed to hang on pretty well into active phase, second pulse of the active phase, into mid to late December sort of time frame. So a good little window there. And then things get quiet after that for a while. So we'll see how it goes. But for right now, the future is looking pretty good. All right, if you enjoyed the video, please leave us comments. Hit the thumbs up button. We always appreciate it. If you haven't subscribed, you can subscribe. The subscribe button's right down there below. You can put in your email address. I think there's a little bell next to that. Every time we update the video, you'll get a notification. If not, you can just go to stormsurf.com. Just about all this data here is on the site. You can follow the models yourself during the week, and then we'll update you on the weekends. Hope you enjoy that. We enjoy doing this. It's a lot of fun. All right, so we'll see you next week. Same time, same channel. Thanks for watching.